For the last four problems here, it's a combination of goal 37 and 38. We want to be able to draw a free body diagram and then use it to find the net force. All right, so for this first one, we have a person on a cliff, and they're pulling up on the person hanging from the rope with a force of 1,000 newtons. So here, and it wants to have us draw the free body diagram of the person hanging. So here's my person, and his weight force is 300 newtons. But the applied force up, right, so that's my tension force working up, is going to be 1,000 newtons. Okay, so to get the net force, I'm going in opposite directions. So I'm going to find the difference. 1,000 minus 300 equals 700 newtons. The 1,000 is the greater force, and that is working up, so it's 700 newtons upward. Okay, we have a tug of war going on. You're pulling to the left, your friend pulls to the right. We want to draw a free body diagram for the forces acting on the rope. So here's my rope, and I'm pulling to the left, and someone's pulling, I'm pulling with 600 newtons to the left, so that is the tension force to the left. And then we have a tension force to the right with 200, okay? And then technically we have a little force working downward, but because of these forces, that is going to be pulling up on it, so it would kind of be eliminated with another force working upward. So our net force, we're really just going to be looking at the 600 minus the 200. Okay, so again, there is a little bit of a force working here, that gravitational force, but it's so small that we kind of ignore that. So we have 600 minus 200, that's going to equal 400 newtons. 600 is the greater force, and so therefore that's going to work to the left. All right, we're rock climbing with friends. You slip and fall. Luckily, you're tied to your friends by a strong rope. The rope is going to point straight down. Now, you have a weight of 500 newtons. And one friend is pulling you up with a force of 400 newtons. And the other one is pulling you up with 200 newtons. Okay, so these are tension forces. This is your weight force. And so we need to show, since we know that these are positive forces working up, so that's 400 plus 200. These are my upward forces. But this one's going down, so I need to subtract that. That's the opposite direction. So 600 minus 500 is 100. Now the total here up is 600 newtons, so this is going to be a greater total net force upward than the downward force, so this 100 newtons is going to be working up. And then the last one, we have an object being pushed to the right with a force of 10 newtons. A friction force is to the left with 4 newtons. And we want to draw a free body diagram and represent the force. Now technically, if you're being pushed left and right and you have a friction, you must be on a surface. So you really have a gravitational force and a normal force, and these two are equal. All right, so Fn is going to equal Fg. The other forces then are going to be 10 minus 4, which is 6 newtons, and it's going to be to the right. Okay, so looking at this page here, this one's good. We have our normal, our gravitational, and our forces. Here, we have 2 people pulling up, so you're going to have 2 arrows up. Here, I would say you probably aren't even going to have this force on here. If this is the diagram, you're more likely just to be paying attention to the tension forces, because we're trying to kind of simplify this for you guys, and really what would be happening is there would be an upward pull on both ends to eliminate this, but since we're only working in one dimension, we are only going to worry about the tension forces here. And then for this one, we only have the up and down force. We don't have any forces left and right.